All right, so today, Wednesday, October 13th, we're going to be talking about inheritance in object-oriented programming. This is, again, one of the key principles of object-oriented programming. And hopefully after today's lecture, it kind of makes more and more sense why OOP is kind of the way to go for a lot of design-oriented matters. Because I know maybe right now you're still kind of maybe have that doubt in your head, like, why can't I just use a dictionary to store my data? Well, hopefully inheritance makes it kind of a little more advantageous to use classes, and we'll make the concepts a little more clear. So today we're going to be going over inheritance, talking about maybe different types of inheritance we can have, and focus on that. So let's dive right into it. All right, so inheritance. There's 4 principles of OOP. The one we're going to focus on is inheritance. The other 3 are polymorphism, abstraction, and encapsulation. We briefly touched upon them during our introduction of OOP. Again, good basic concepts to know when you're kind of studying OOP. Again, we're not going to dive into the latter 3, but we're going to mostly focus on inheritance. That usually is the most interesting for us anyway. Before we talk about inheritance in object-oriented programming, could I ask the audience, if you were to describe inheritance, again, just in plain English, how would you describe it? I guess I'll call on someone. So let's ask who I'm going to talk to in a while. Let's go with Kristen Rippert. How would you describe, again, in your own words, just the idea of inheritance in plain old English?
I would say it's getting traits passed down from some kind of parent or ancestor.
Yep, that's definitely one usage of inheritance, I guess, in our everyday world. So that's like in the biological sense, as Kristen said, like, yeah, we inherit items or traits from our parents. So like, I have brown eyes. I assume that's a trait that I got from my mom or dad, or mom and dad. I'm not sure how the genes work exactly, but yeah. So inheritance in biology, definitely a concept that all of us probably understand, of inheriting traits from our ancestors. Great. Can anyone else think of another example of inheritance just in everyday life? All right, I mean, yeah, so I definitely think of the biological example. The other inheritance, when I hear the word inheritance, sometimes I think of, well, when you inherit money, like, you might have a grandparent that passes away and maybe they leave you $100, or, hopefully a little bit more than that if they had a nice nest egg. But if you guys ever play Monopoly, there's a community chest card where you inherit $100. Monopoly is an old game from like maybe the 40s, maybe earlier 20s. So I don't know if they adjusted it for inflation. I know they have like 20 different varieties, so there's probably a more inflation adjusted variety, but this is a community chest card from the original game. All right, so again, hopefully all of us understand the general idea of inheritance, again, just to normally speak. Luckily, in object-oriented programming, the usage of inheritance is basically the same concept. So in object-oriented programming, inheritance is a mechanism where properties, and so when we say properties, we mean specifically for classes, attributes and methods. So again, just to review, attributes are data members or variables that we store inside of our classes, and methods are simply functions that act upon those data members. These properties are passed down from parent classes down to child classes. So as kind of Kristen said, for the everyday example, we have parents or ancestors, grandparents, we get traits passed down from them to us, but keep in mind that it's only one directional, as in I don't really impact my parents in terms of like traits or anything I pass to them biologically, right? It's a one-way channel. In the same sense, for inheritance in OOP, parent classes pass down items to child classes, but child classes do not really give back anything to parent class. So if we stated that another way, child classes inherit properties from parent classes, hence the word or the usage of inheritance. Right? Why do we want to use inheritance? So it offers a number of features to us. Again, one is to create a relationship between similar data types. So, if we have, let's go with, we're going to be using this example throughout today. So, the idea of a shape. A shape has, definite properties to it, but then we could have like a more specialized shape. So for example, the idea of a shape, and then we can think of the idea of a rectangle. A rectangle has more definite, concepts to it. It might have some additional properties that a normal shape wouldn't. Like, rectangle definitely has 4 sides. versus a shape can have any number of sides or even, curves or whatever. But yeah, so we'd use inheritance to kind of relate those two ideas, because a rectangle and shape do have related items, right? Like they both take up area, they both, I guess, can have a circumference, many related ideas. So that's what shape would provide, but a rectangle would add on to that idea. Going off of that, so inheritance, when we're coding, helps us reduce redundancies or repeated code, and by that effect, increases reusability of our code. So that means we don't have to keep typing the same thing over and over, or the same concept, or creating the same block of code to do similar things. We can kind of leverage past code that we wrote and add on to it, rather than, again, reinvent the wheel per se. And then also, one additional benefit of using inheritance is that if we need to make modifications to our structure, it makes things a lot more easier and a lot more seamless. Because again, if you go back to our shape example, let's say we need to add a method to shape. Let's say we have area, but we need to add circumference. Well, we could just add it to one place and it'll automatically be applied to everything that's related to it. So we don't need to, let's say we had 50 different shape classes. Well, instead of going through each 50 shape class and having to add the same thing that might be generic, we could do that in one place, and kind of make that a lot easier to maintain. Obviously, area is not a good example because each shape has a different way to calculate area, but hopefully the point was made. All right, any questions on inheritance at a high level? All right, just a lot of terminology here. Let's actually see some examples. So in Python, how do we actually employ inheritance? So up until now, we've just creating classes and just implementing them and using them, which is fine when that's all we need. But if we want to create a child class, the additional syntax is shown here. So we add parentheses after the name of our class and add in the parent class. So in this case, my classes happen to be named parent class and child class. That's just names I chose. Again, you can name your classes whatever you think is appropriate. But again, the syntax here is add parentheses and pass in the name of the class you want to inherit from. So in this case, my child class is inheriting anything that the parent class has in it. Obviously, right now we just have pass statements, so nothing actually is being passed. But that's our syntax. Keep in mind, for declaring just a general parent class, you can add parentheses here, and sometimes coders might do that. So you might see empty parentheses here. That doesn't change anything at all. That just means we're inheriting from nothing else. Otherwise, everything else is the same. All right. So
thank you for that. I was so confused about that.
Gotcha. Yeah. Usually I omit the parentheses if I'm not inheriting from anything, but I can see an argument for being more consistent by adding parentheses. But yeah, they do the same exact thing. So you might see either or. Yep.
Yeah. Now that makes perfect sense though, because with inheritance, and then you pass in the parent class. Okay.
Yep. All right. So some other terminology you might see. So base class and derived class instead of parent class and child class. I tend to use base class and derived class, but I sometimes might say parent class and child class. Again, if I interchange those, apologies, I'll try to be consistent. But just understand there's different terms for the relationships here. So they mean the same thing, it's just different terms. So parent child class, you might see base class, derived class, and then you might also see superclass and subclass. Again, same ideas, just different words for the same thing. All right, so there's different types of inheritance models that you will generally see depending on your use cases. So first we have single inheritance. An extension of that is multi-level inheritance. There's also multiple inheritance and hierarchical inheritance. I always have trouble saying this word, so I'll try to avoid saying it as much as I can. But let's actually look at these models and kind of just see what the structure looks like. So single inheritance is the simplest kind of inheritance model. It's where you have one parent class or one base class and one derived class. So in this diagram example, we have class A will be our base class. It's going to pass down properties to our derived class, which is class B. I want you to pay attention to kind of this scale that I have here. Generally speaking, I don't know if it's even more than general. Your base classes would be your more generic concepts. So an example that I had of shape and rectangle, shape would be your base class because again, that's more abstract, right? And then when we try to specialize more, like rectangle is a specialized version of a shape. That's why rectangle would be a derived class of shape instead of the other way around. Like it could work for whatever you might be doing. You might be able to get away with having rectangle as your base class and shape as your derived class. But again, that's not the proper design because again, conceptually, that doesn't make sense. Like shape is not a version of a rectangle. A rectangle is a version or a type of shape. Right, so the more you derive a class, the more specific or specialized it should get. And this makes more sense when we talk about the next kind of inheritance, but let's see a quick example. So as we're talking about shapes, simple example here, we have class shape, and then we inherit from shape, again, parentheses, add in the class name, and then that allows us to access anything that shape has. We can access that from rectangle. We're gonna go to our curriculum page because I added some more detailed examples. So we'll skip over our dog example. Well, let's go down to shape and let's talk about the code here. So let me add, let's say, lecture.py. All right, so again, just to reiterate, as I mentioned before, typically speaking, when you create a class, each class should get its own file. And in fact, since I said that, I'm going to do that instead of taking the shortcut. So I'm going to create shape.py, and I'm going to create rectangle.py. And then I'm going to move shape into there. Actually, this might get confusing, so yeah, normally you want to move them into separate files, so I'm going to do that just for that. And then in this case, I'll need to import shape. All right, but for our lecture purposes, I'm going to keep them in one file so we can look at both. Apologies for bad practice. But let's look at this. So our shape class has a class level attribute, and we're just going to default that to unknown. And then we have a string method that simply prints out the type. Our rectangle class inherits from shape. That means everything that shape has, we have access to here. In this case, we are overriding the type value here, and that's a terminology we'll get to. Basically, every rectangle is always going to be like a type of rectangle, right? So that's why we're going to have that be a class level attribute. But more interestingly enough, rectangles have specific properties. Specifically, they have a length and a height, or maybe a width. I'm not sure which is more proper, but they have a width and a height. So that width. And yeah, and we can calculate the area. We have a definitive formula to calculate area for rectangle. It's simply the width times the height, right? So that's the area of a rectangle. The area for a shape, that's a little more hard, like it's harder to compute, right? A shape can be any blob. There's no definitive formula, so maybe we don't have an area function in our shape class. Again, these are design decisions that we're making. But the main takeaway here is that this string method will be inherited by rectangle. Notice that rectangle does not have a dunder string method, but if I coded this up or had instances, let's create r equals rectangle, pass it a width and a height. So let's say it's a 4x5. I could do print r the area, because that's the instance method, right? We pass in self, or self gets passed in automatically. We compute the values by multiplying width and height. But we also do simply print out r. If we do this, let me run it by doing control tilde, Python, lecture. All right, notice we get 20, which I would expect because 4 times 5 is 20. But also when we print out r, we actually get the type printed out. And the reason is because we have this str method that again exists in the shape class, but it is accessible by a rectangle via inheritance. All right, any questions there? All right, so again, this is simple, like simplest form of inheritance, single inheritance. All right, let's get a little more complicated, but not too crazy. Let's talk about multi-level inheritance. Again, this is just an extension of single inheritance. So you think of it as grandparent, parent, and child, or maybe parent, child, and grandchild, whatever. But in this case, we just have more levels. Instead of just one and one, we have 3 levels in this case. But theoretically, you can have as many levels as you require. You could have 50 levels of classes if that makes sense. Don't just do that just for fun. You should have a use case where you need 50 different levels of specification. In this case, we have one base class that we create a derived class, class B, derives from class A. But then we also happen to need class C, which is a further derivation of class B. All right, so we want to see an example of this. We could talk about having shape as a base class. We would have rectangle as a type of shape, but then we have a more specialized rectangle, which we would call square. Square is a type of rectangle, but it's more special than that. It's a special rectangle that has equal sides, right? So if we needed to create like a square object, we would create a class for it. Again, we don't have to. We could probably use rectangle class as we had it before and just pass in the same width and height. That would do the job for us. But if we're going to be using square often enough, it makes sense for us to create a specific classification for it, right? And the way I kind of explain that is think about just the English language, right? We could definitely have a description for what a square is without the word square, right? If I was just talking to Guillermo, because he's on my screen right now, I could just say, hey, I'm going to draw a rectangle that has equal sides on all four sides, right? Every time we talk about that, we will just say rectangle with equal sides, right? That gets a little verbose. So obviously someone in the past decided, since we're using that terminology again, let's define a new term and call it square, so that whenever we refer to square, everyone automatically knows that means a rectangle with equal sides, right? That's how definitions work. That's kind of why we're creating a definition in our code. So if we want to add that, let's grab square. I don't think I changed anything else. There's width, so I'm not sure why I had length before. I'm going to drop that here. All right, so we still have shape. We have rectangle, but now we have this specialized square class, which inherits from rectangle. So again, it's multiple levels of inheritance. Rectangle gets everything from shape. Square gets everything from rectangle, but by inheritance, square will also have access to everything that shape has, because shape passed everything down in the rectangle. Rectangle is passing everything it has and everything it has inherited down the square. So if we look at square, it's very simple, and this is bad syntax. Sorry, let me clean this up, so otherwise it won't compile. So square simply has an init method that takes in one value. That value is L for length or side, whatever you want to call it. Couple things that are definitely worth pointing out here. I did mention in the past that you should never call dunder method yourself. Well, this is one exception to it. In my init method, I want to initialize everything a rectangle needs to initialize also. So in this case, I am calling the init method directly on rectangle. Now this should only be done within your own init method. So square has an init method. We need to initialize its base class. In this case, the base class is rectangle. So we're passing down the side and the side again so that the rectangle has the width and the height. All right, so again, this is an exception to the general rule we talked about. For the most part, you should not be calling dunder methods yourself, but the init method is one exception to that rule.
Ankur, can you say that again? Sorry, that I got really lost right there.
Yeah, absolutely. So square, let's say we want to initialize a square. So I'm going to initialize a square, and let's call it square class. And the square is going to have, let's say, sides of 7. All right. The whole purpose of creating the square class is because I don't want to specify, two different lengths, because both of those lengths are always going to be the same for a square. So the initializer for square takes in only one measurement, which I've called S for side, right? But the rectangle needs a width and a height, right? A square is a specialized rectangle, but in order for rectangle to have its, members initialized correctly, we need to pass down a width and a height. So when I create a square, I pass 7 into the initializer for square. We know that a square is just simply a rectangle with the same sides. So we need to initialize the base class, as in we need these values to be populated for our needs. Notice that we're not storing side within our square class, right? I don't have self.side equals S. I could if I needed it, but rectangle already provides that functionality for me, right? Rectangle is keeping track of the width and the height, which effectively are each of the sides for my square. So I'm not storing additional data with my square class, but I am passing down data for my rectangle class. So I need to manually call init for my base class, which in this case is rectangle, so that my width and my height get values set onto it, right? Because in my initializer right here, I'm only passing one value. That value needs to be passed down to rectangle as 7 and 7, so that we have a width and a height for our rectangle logic. So notice again, square does not have an area function. The reason we don't have an area function, or sorry, an area instance method, because rectangle's instance of area does the work for us. Calculating the area for a rectangle and a square is the same thing. It's width times height. For a square, it just has to be side times side, but this will do the same thing because width and height will be the same because we initialize it with the same value. So I can still call area. I can do SQ area. And if we do our mental math, that should be 49. And we get an error. Sorry, this needs a self in that. All right, so we have 49. I forgot to add the self here. So again, we are manually calling this donor method. This is, again, one of the rare cases where you need to specify self. Normally, Python will automatically pass it for you. But since we're calling a donor method directly, we need to provide that parameter ourselves. So again, the syntax here looks a little weird, but basically you're calling the base class, in this case rectangle. The init method must pass the self, because self is required here. And again, Python is not adding that self for us in this case. And then the parameters like normal. All right, so we get 49 as our area, which is what I would expect for a 7 times 7.
Andres, this is the reason why you separate the classes, because then it becomes way too hard to keep track of everything all on one page.
Yeah, I mean, just definitely for right now, yeah, it's probably hard for you guys to kind of see me scrolling over and over. That's not the main reason for separating it to modules. The main reason for separating out to different files is so you can reuse the bits that you need instead of reusing like a whole library, right? So let's say I only wanted to use rectangle and I don't care about square, then I can import rectangle and not have any square logic that's kind of being added in. So it's more for modularity, not necessarily for readability. But again, it does help for readability. Think about if I had 100 classes in one file, I'm gonna be searching through it, hopping back and forth. So it does help with, again, organization and readability at some level. Okay, cool. So that was an example of multi-level inheritance. Again, just the idea of passing down multiple levels. Next up, we have multiple inheritance. This is a design or a model for inheritance where we have multiple base classes. So in this case, we have A1, A2, A3. All these are acting as base classes, and they're each individually passing down properties down to a derived class B. If you think about it, this is probably the more suitable example for like parents and children, like in real world. So we each, have a mother and father. We'd have two base classes, A1, like a father class, a mother class, and then they would pass on traits down to our class if we were, kind of modeling that. Obviously, we wouldn't have 3 parents. That's probably not biologically possible. But again, there's no limit to how many base classes you can have. You could have 2, you could have 1, you could have 17, you could have 384 base classes if you needed it. Again, if you have the use case for it. So there's no theoretical limit to how many base classes you can have. Let's see an example of this. So kind of diving a little more into geometry. Rhombus is the term that we've dropped in here. So just to review, a rhombus is a shape that has equal sides, 4 equal sides. That's a little different than a rectangle, where a rectangle has two pairs of identical length sides, but they don't necessarily have to be equal. Rectangles have right angles, so every angle is a right angle, versus a rhombus does not necessarily have to have right angles. In fact, most of the time it does not. Both of these have properties that square can benefit from. In a sense, rectangle offers, right angles. That's what a square has all right angles, right? And the area formula we could absorb from rectangle. We can also absorb it from rhombus. Rhombus provides the equal sides portion of it. So a square both is a rectangle and is a rhombus. So hypothetically, if we needed functionality to code up functionality in both rectangle and rhombus and use that in square, we'd use multiple inheritance in this case. Notice the syntax here. We still use parentheses. Now we separate our base classes by commas. So in this case, if we have 2 base classes, we add 1 base class, comma, second base class. All right, let's, again, this wasn't the greatest example because I don't know too much about rhombus shapes, but I do have it coded up here. So let me drop that in here. Terminal can go away for now. All right, so I took shape out of the equation right now just to focus on multiple inheritance. So we have rectangle, we have rhombus, and we have square down here. Notice we have area for a rectangle is still width times height. Rhombus, I had to look this up, but the formula for calculating the area is given the side lengths, it would be the side squared times the sine of one of the angles. It doesn't have to be the minimum angle. It could be either angle because they're going to be complementary. Again, these are geometry terms. Basically, they add up to 180. Each pair of angles adds up to 180. Anyway, so you take the sine, multiply it by the side squared, and that will give you the area. So both of these should give you the same answer for a square. So in this case, when we initialize our square, we need to initialize both base classes. Rectangle needs some data. In this case, they need the lengths. But rhombus needs a side and both angles. So in this case, we're passing down S, and then we also have a self dot angle. Well, where's that self dot angle coming from? Well, notice we added an angle to rectangle, right? Because every angle in every angle in every single rectangle that's going to exist is always going to be 90 degrees. In this case, we need to convert it to radians, but it's always going to be 90. So that's why it's a class level attribute, right? Because every angle is a right angle and a rectangle. And then we're using that self dot angle and passing it down to rhombus because that's what our angle is for this specialized rhombus, right? A rhombus can have, 30 degrees and 120, but a square is a specific type of rhombus that always has 90 degrees angles. Okay, so again, just keep in mind how we're initializing both base classes, but otherwise this would work as normal. So we called print, oh, I still have the code here. So we called print area. Notice we still get 49. That's the correct answer. The question is, we have two area functions. We have one coming from rectangle. We have the other coming from rhombus. Which one did it actually use? Obviously, both should produce the same answers because the formula should be correct. But we have two methods called area, and we called area on square. Square does not have its own area instance method. It's inheriting it both from rectangle and or rhombus. So it's kind of ambiguous right now which area function is being used, but luckily we still get the same answer. All right, so stay tuned for the response to that. There is, I do know which area is being used, but we will find that out further on into the lecture. So stay tuned. Okay, let's get to the last main type of inheritance model, which is hierarchical inheritance. This is kind of just the reverse of multiple inheritance, where you have one base class, in this case, base class A, and you create multiple different derivations like B1, B2, and B3 from the same base class. So simple example, continue on with our shape theme. Our base class might be shape. Then we might have different kinds of shapes, like rectangle is a shape, triangle is a shape, oval is a shape. But keep in mind that rectangle, triangle, and oval, they don't necessarily share similar things between them. Like a rectangle and triangle, they have some different ways to compute area, they have different number of sides, holes to different things. So that's what we implement in each individual class. But anything that's shared by all three would go into the shape base class. All right, so that's the whole purpose of having a base class, is so you could kind of aggregate similar functionality in one place rather than having it repeated in 3 or 7 or 20 different places, depending on how many derived classes you have. Okay, so I do have this coded up on our page also. Let me grab that. Okay, let me paste that in here. And this will be our last example for this thread. But again, shape, rectangle, triangle has a different area function. So we need to implement that here. We can't inherit that just from shape because shape has no, there's no generic area for any shape. And oval does its own thing, right? Oval's taken 2 radii, the radiuses, and the formula for that is R1 times R2 times pi. I did have to look these up. My geometry J's are well behind me, so definitely Google the area functions here. But again, same idea, just as many derived classes as we need, we would create them in the manner of speaking. So again, you can create as many derived classes from one base class as you want. All right, so we talked about the 4 main models. There really isn't a 5th one, but there's a 5th concept, and that concept is hybrid or combinational inheritance. And I just say this is as much chaos as you need. As you work on like real world projects and like large projects, you'll probably see models that look this unappealing. Like it can get pretty crazy, especially with super large projects. So again, this is not atypical. Again, this is a random example, but again, you can have, this is a combination of where you have multi-level, where you have A1, B3, C2. That's a multi-level example, but you also have, multiple inheritance where you have A1, A2, A3 going into B4. You also have hierarchical where A1 drives down to B1, B3, B4. Again, you could skip levels. So notice A3 is going directly down to C3, but also A3 goes to B4 and C3. Again, it gets pretty complicated. If you want to see an example here, no thanks. I'm not going to code this up necessarily because that's a lot of coding and a lot of chaos. I probably would forget what I'm trying to implement here. I did stub out something that makes sense. I'm going to copy that from our curriculum page. And again, I haven't implemented these functions, but hopefully you guys kind of get the idea where you could have real world cases where you need to do this. So here I have shape as a base class. I also have something called polygon. And just a geometry refresher, a polygon is something that has a definitive number of sides. Most shapes that we are familiar with are polygons, but not all shapes. So circles are actually not polygons because they don't have a finite number of sides. So if you go down to circle down here and oval derives from shape. But the rest of my buddies here, notice I have rectangle, I have square, or sorry, I guess what I have here. There, I have equilateral, which derives from polygon. I have rectangle, which derives from polygon. Triangle is a polygon. Again, most shapes are polygons, but not every shape. That's why I have this additional intermediate class called polygon. So I could have everything specific to polygons, like, for example, I might have number of sides, and this would be specific to all polygons, but circle obviously would not have a number of sides. What else? Equilateral, just geometry refresher. And equilateral is something that has, each side has equal sides. So rhombus, as we talked about earlier, is an example of an equilateral because it has 4 equal sides. But we'd have more equilaterals, like an equilateral triangle, as what the name would imply, is a triangle that has 3 equal sides. So the reason I created an equilateral class is because both rhombus and equilateral triangle can inherit similar properties from the class of equilateral. All right, so again, you guys can kind of walk through this. Again, there's no functionality, but hopefully the design of this makes sense. And that's an example of hybrid or combinational inheritance, where we have multiple classes interacting with one another. All right, so that was our intro into different types of models. Again, you'll be working with this, creating different types of models based on your use cases. So just kind of understand when one makes sense over the other. Obviously, if you just need a chain where like, boom, 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 you use multi-level. Or if you have multiple conceptual ideas that combine together, that's where multiple inheritance obviously would make sense. Again, in our example, we had the idea of a polygon and an equilateral. Well, yes, they can be combined so that you could have, a rhombus or equilateral triangle or a perfect polygon, whatever you're trying to create. And then, yeah, hierarchical, opposite idea, where you have one generic idea, but multiple derived ideas. Any questions on any of the models that we talked about?
Encore, when you were talking about multi-level, I think it was multi-level, maybe it was multiple, but you had posited the question, which of these equations is it using to calculate area?
Yep. So the example was from multiple inheritance. So hypothetically, let's say A1, A2, and A3 have the same method implemented, and then B wants to use that method. Well, it's getting 3 different iterations, or not iterations, 3 different implementations of the same method. So if B calls like B do something method, which one is going to use? Is it going to be from A1, A2, A3? Yeah, so that is an open question, and we're going to answer that shortly. So stay tuned. Any other questions on our models here? Again, our curriculum page has good examples. I added them recently, but they kind of just walk you through how you might design them, how they interact. So again, you don't need to, the whole point of inheritance is that you don't need to recreate things that can be shared. So area doesn't need to be shared for or recreated for square in our example above, because again, the area of a rectangle, that formula can be used for square. So we're saving, again, redundancy here by using area both for rectangle and square, even though square might have some additional specialization to it. Okay, let's take a quick break here. It's 11:07. Let's take an 8-minute break. Please be back by 11:15, and we will continue our inheritance lecture. And again, if you guys have any questions that pop up over the break, definitely ask them after we get back.
So why don't you use the super method here?
We will be using the super method. So yeah, you're a bit ahead of the game, but yeah, good that you know about it. So the super method is a method in Python that we will be using to access base class functionality. Yep. Yeah, so stay tuned for that as well. Any other questions about inheritance? Okay, let's continue on then. We went through our examples, multiple inheritance, hierarchical. All right, so we're going to talk about a few more advanced topics. Not all of them are like super advanced, but we've been covering inheritance versus composition, kind of just talking about what each is and when you choose one or the other. When we talk about overriding versus overwriting, unfortunately, those words sound really similar, and they also have similar conceptual definitions, but there's a difference between those. Just want to differentiate overriding versus overwriting. We'll briefly talk about abstract base classes. This gets a little complicated. I will just note ahead of time, and hopefully I'll mention it when we get to it. Abstract base classes, don't worry about it if it's confusing or it doesn't make sense. You're not going to be using it really. It's just a good idea to know about. Also, the method resolution order, also known as MRO. We'll talk about it. Again, might get a little detailed. Don't worry too much about it. You're not going to be using it. We're not going to quiz you on it, but it's important to understand that it exists in the context of using super. So yeah, Ping mentioned the super method. We're going to be talking about that, and the MRO is kind of crucial to understanding the super method. All right. So before we kind of get into some of our topics, let's grab some code here that I've coded up. I'm going to paste that into our window. All right, so I'm going to shrink my window because we have a lot of code. Let me know if it's too small for you guys. Can you guys read that, or is that too small?
That's good.
Okay. Again, this code is provided on the curriculum page, so you guys can reference that if my screen is too small. But I've coded up a few classes here, and I'm using inheritance. So I have an animal base class. I have a fur class. I have a mammal class. So a mammal, hope you guys remember from biology, is a specialized type of animal that has fur or hair. We are mammals. And then I also have a dog class that is a type of mammal. It's a more specialized mammal, or more specialized idea than a mammal. And then I have my runner code down here. So let me make this a little larger. I don't know if you guys read the Clifford the Big Red Dog books when you guys were younger. They were great children's books. If you've not heard of them, or if you have children, introduce them to them. They're nice, nice little stories. Basically, Clifford is a giant dog and just gets into adventures and trouble. So anyway, so I've specified a number of attributes I want to store on certain levels. So taking a look at my animal class, for my purposes, obviously there's a lot to being an animal, but I want to store the diet type, as in if they're omnivore, carnivore, herbivore, and also their weights, because every animal is going to have a weight and every animal has a diet, right? Everyone's got to eat. So that's what I'm storing in my animal class. Then I have a fur class. So like, again, fur or hair, like again, we are mammals, so we technically have fur, but there's fur color, also a length, like, certain animals have really short hair. Some animals have really long hair. Also the style. So like, I'm thinking about some animals have really thick hair. Some animals have like curly hair. Some animals have really thin hair. I don't know. There's different styles of fur that exist out there. So I created those attributes in my fur class. Then I have my mammal class. So my mammal class, again, is a combination of animal and fur, because mammals are animals that have fur. So in this case, my mammal class doesn't have any extra, or I guess it does have extra data, which is primate, because in order to be a primate, you must be a mammal. So I want to track that here instead of in my animal class, right? Because you can never be a primate if you are not a mammal. But most of my other data is being passed down to my other base classes. So mammal is using multiple inheritance, where it inherits from animal and fur. And notice we're passing down diet and weights down to animal. We're passing down fur color, fur length, and fur style down to fur, because those classes keep track of those particular data for us. Finally, I have a dog class, which inherits from mammal, because a dog is a type of mammal. And then I also have additional parameters, name, breed, and then also the other required ones, such as weights, fur color, fur length, fur style. So I store name and breed on the dog level. That's specific to a dog for my use cases. But then we pass down other values down to our mammal class. Notice that our hard code omnivore here, because all dogs are omnivores, right? Sure, some dogs might only eat meat, but all dogs are capable of being omnivores. So they're omnivores, weight is specified by the user, etc. All right, false, this is dogs are not primates. So that's what this false is for. Notice it's mapping to the primate. All right, cool. So again, a lot of details here, a lot of data we're keeping track of. I probably overcomplicated this idea, but basically all I want to do is print out the value of Clifford. Notice I have an str method here, so it's going to leverage that. So I'm going to run this code and let's see what it prints out. Clear, and then I want to Python lecture. All right, notice I get an output that looks kind of reasonable. Clifford is a dog that has medium red shaggy fur and weighs 4,000 pounds. Again, Clifford is a big red dog. So if you are unfamiliar with them, definitely Google him during one of our breaks. But he's a big dog, he's red, and not sure what breed he is. So I just put down giant. I know that's not a breed, but I don't think, I was actually researching this last night. And according to the author, there's no breed specified, but some people have guesses as to what the breed might be. Anyway, those are details. All right, my main question here, open question for the audience, is I get what I want here. My dog has the appropriate attributes. Again, I'm storing the weight down in the animal, right? Omnivore, sorry, the weights. I pass on omnivore, but not using it, but that's fine. That's because my str method is just not printing it out. Again, I do have access to it, so if I have self.diet, it would print it out. I just, for a reason, my description of dog, I didn't want to use the diet here. So again, I have name, that's coming from the dog level, the length, color, and style, that's coming from the fur level. I also have weights, that's coming from the animal level. My question to you is, what's wrong with my code here? Can anyone think of anything? Again, it's okay if it's not apparent, because again, this is the concept we're going to be detailing. But the whole point I wanted to show here is that this works. I get exactly what I wanted, which is I get the details, and I was able to access the values and print them out. This 100% works for what I want it to do. But this is not proper OOP design. And the reason is this fur class. All right, so keep that in mind. We're going to come back to this example in a short moment. But that's where we talk about inheritance versus composition. All right, so we're teaching inheritance today. The key takeaway from this slide is that, sorry, not this slide, but this concept is just because you can use inheritance doesn't mean it's always the right design choice. That's what I want to kind of solidify here. So you can use inheritance and it might work for you, even though it's not the proper design. So generally speaking, inheritance should be used for is-a relationships. So in this case, a dog is a type of animal. Therefore, if we create a dog class, it should derive from the animal class. Otherwise, it should inherit from the animal class. Maybe I should write inherit instead of derived, but they mean the same thing. Same thing with a square. A square is a type of shape. Therefore, a square should inherit or should be derived from a shape class. Right? So is-a relationships should use inheritance. Composition, you guys have been using composition, but we didn't give a formal name to it. Composition are used for has a relationship. So this is where like a dog has a name. That's why we store a name as an attribute inside the dog rather than inheriting from some name class. It's a little more apparent when you have multiple of something, like a square has angles, multiple angles. Well, square should not inherit from an angle object, right? So what I mean by that is, I go down here. We could, but we shouldn't, do something like class angle pass, and then do something like class square angle, 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 angle. I think that might work in Python, but again, this is wrong. Just because it has 4 angles doesn't mean we should use, you shouldn't be like, oh, okay, well, we have 4 of something. Let's just use multiple inheritance and inherit 4 times from the same thing. Again, this is not proper design, and I'm not even sure if this is legit syntax. It might be possible in Python. I'm not going to explore that avenue because, again, we shouldn't be going down that avenue. But again, just the easiest way to determine if the relationship is a is-a or a has-a. Obviously, we're all capable of mangling English as we so desire. Again, just keep it the simplest form. So like I could say something like Clifford is a dog with red hair, right? I didn't use has-a in there, right? I said is-a, or I could say Clifford is containing red hair, whatever. You guys kind of get the idea. Just don't force yourself into is or has-a. Kind of just whatever makes natural sense. So in this case, a dog has a name, so name is an attribute. A dog is an animal, so animal is a parent class for our dog class or a base class. All right, so going back to our example for Clifford, again, I was able to make this work because, fur, I'm deriving from it, but that's not actually what I should be doing because a dog is not a type of fur, right? A dog is something that has fur. So instead of using inheritance, I should be using composition here. And simply what that means is instead of deriving mammal here, I'm still going to keep my fur class. Creating that fur class is not the wrong part, right? If we still want to bundle data together in some conceptual unit, fur makes sense if we have multiple properties like color, length, and style, which are all tied to fur. But yeah, this fur class is totally okay and probably recommended. But instead of deriving from it, again, I took away the derivation by removing fur from here, right? We're deleting that inheritance, and instead we're going to add a attribute called fur and instantiate a fur object. So we'll do fur, and then fur color, fur length, and fur style. All right, so essentially it's the same, we're getting the same results. If I delete this, again, I don't need to call base class because there is no fur base class here. But I am still using the fur class, but I'm creating an attribute, an instance attribute of fur instead of deriving from fur. All right, so we make that change, and the only thing we need to change now is access.
Hey, Alger.
Yep.
Oh, sorry to interrupt. Why are we using self dot fur instead of capital F fur dot fur?
Good question. So self.fur, I'm creating an instance attribute. This is just a variable I'm creating. So I can name this, fur details. Again, this is just a variable. It's the same thing as is primate or name or breed. We're just creating a new variable. We use capital F for when we want to create, actually use the class to create an instance. So here, I don't want to do this because this would work because this is just a variable with a capital F as a name. But this is kind of confusing because this might lead someone to believe that I'm doing something with this fur class over here, right? Right now, I'm just creating a variable that is called fur. It's not referring to the fur class by any means. But on the right side here, I am creating a fur object and assigning that as my instance. All right, so again, if you think about this is basically you're having a nested class, a class nested with another. So the mammal class has another attribute, which is it happens to be an instance of another class, which is what the whole idea of composition is. You're just kind of composing the mammal class by using other classes. All right, so now that we changed this, we do need to make one more change, and that's how we access the data. So previously, I'm just going to change this back temporarily. When we were inheriting, we had access to color, length, and style directly from self because dog was a mammal and mammal was an animal and a fur. Therefore, we can just do self.length, self.color, self.style. But now that we are no longer using inheritance, we have a new attribute called fur. But that fur instance has additional properties of color, length, and style. So in order to access what we want, we need to add self.fur.length, self.fur.color, and self.fur.style. I'm going to leave this up for a few seconds to make sure we can digest it. But again, kind of understand how we're accessing the data appropriately. Self is our instance. So self in this case is Clifford, which is a dog instance. So if I wanted to, I could kind of imagine this as, oops, Clifford.fur. But obviously this function has no notion of what Clifford is, but it does know what self is. So replace that with self. But if I wanted to access, fur details outside of my outside of the class, I could do, print Clifford.fur.color. Again, Clifford is a dog instance, so we're in our dog class. Fur is an instance on our mammal class, but we still have access to it from dog because we are inheriting everything from mammal. So we add access to fur, but fur is an instance of the fur class, and that has additional properties. So we are going from dog down to fur, and then through fur, we are getting the color. So if I ran this, we should get red printed out, assuming I have no errors here. So I do Python lecture. All right, notice we get Clifford as a dog that has medium red shaggy fur. That hasn't changed. Again, it worked the same before with inheritance, but inheritance with fur was the improper design because it should have been composition instead of inheritance. Otherwise, we get the same output, and then we also get red printed out because we're accessing the color through fur, through dog. What questions do you guys have?
Ankur, on line 15, where you declare that variable self fur equals, why do you have to call it self? Would it work if you just said fur equals class fur and then the parameters?
You mean like this or like this?
Yeah. No. Fur and then equals fur parentheses.
Yep.
Why would that work?
This would not work, but it's
Why?
an excellent question. So I'm glad you asked it. Keep in mind, all of these are they're just functions. Like, again, ignore classes for one moment. Like when you create a function, let's just go back to functions. So if I create, def do something, I don't know, X and Y, I can create a new variable in my function, right? X plus Y. But the thing is, if I try to do print Z, that's not going to work. Guillermo, you agree with this? Yeah. So in this case, we're creating a variable in our function, but once our function dies or goes out of scope, Z does not exist. It does not persist outside of this function. The same concept applies for variables in our instance methods. So here, we are creating a local variable that after this function is done, as in we execute it, fur goes away. As in we created something cool, but then we toss it away after this function went away. The whole magic of self is that this self is something that exists outside of the scope or outside of the life of this function. In our case, right now, it's Clifford. Clifford is going to exist even after it gets initialized or any method that gets called. So the whole magic of self is that this is Clifford holding on to a variable so that now fur is still going to exist even though this function is out of scope. But that's a great question you asked. Again, a lot of students kind of have trouble with that. It's very easy to forget the self, but then you'll run into issues because if I had fur here, fur down here is not going to exist. It's going to look for self.fur and say, hey, you never created that because this is not actually creating it on self. It's creating a local variable independent of our instance. Great question. What other questions you guys have about this example?
I think I was just confusing myself, but the on line 22, when you pass in fur color, fur length, and fur style, I was trying to understand it. It seemed like self dot at the beginning of those would make sense, but I guess I'm just confusing myself.
Sure. No, I don't necessarily think you might be confusing yourself, but it's definitely worth mentioning. So the reason you can't do self dot fur dot length is because the init method is actually creating those values. So self dot fur, right? Like when we get to line 20, does not exist. What actually creates is when we call mammal init, we're going to get into this function, and this function will actually create self.fur here. So the whole job of init is to take in inputs. In this case, the user specifies all these inputs, right? We specify Clifford, Giant, 4000, red, medium, and shaggy. We're taking those values and registering them or storing them on our instance. And the way that's done is via init. So again, we pass these values. We just need to stick them onto our instance. So we stick the ones specific to dog here, but that's one specific to mammal we do within the mammals init method. Yeah. So
Gotcha, thank you.
good thought, great question. But yeah, we can't access this value because it does not yet exist. Our whole job right now is to create it by passing down values and assigning them in appropriate places. Other questions out there?
Yeah, I'm sorry, kind of tailing off of Morgan's initial question on line 15. So is that variable that you made, is that just like referring to the class of fur, or is that just its own thing within that class of mammal?
When you say referring, I guess I might amend that or modify that to say it's creating a fur instance. So again, we have this fur class. The concept of fur is totally independent of dog, right? You can have fur, like you think fur for like cats or foxes, whatever. So if I wanted to, I can create a fur instance right here. So let me get rid of this stuff. Let's say we want to create some fur item equals fur, and then let's make it orange. Let's say it's long, and let's say it's, I don't know, thick, long orange fur. I don't know what you're doing with it. Maybe making a coat out of it. Hopefully not, because animals deserve their fur. But if I create fur item, I could, again, this fur item just exists. I created an instance of that. The same way I created a dog instance, I create a fur instance right here. What we're doing here is creating a fur instance, which happens to live within the dog instance. Again, it's like nested classes. So we have a fur instance. This is, again, the same idea as doing self.age equals 17. This is an instance of an integer. It's only, again, it's a little abstracted because this is like a primitive type. So we don't actually do something like int 17. Oops. But this is the same idea. It's an int class with a value of 17. Right? So both of these are doing the same thing. It's just that for primitive types like Booleans or integers, we could just write the value directly. But for advanced types, and this is the same as like with lists, right? We create a list, some data. We normally just do, square brackets to do an empty list, but actually you can call the list class and instantiate a list this way. So list as a class in Python is just a pre-built type versus mammal is a type we're building. So in this case, we're creating a list object and storing that as an attribute. The same thing goes with fur. We're creating a fur attribute. And again, we can create multiple items. I could do, additional fur if I wanted to. And let's say, an animal has like 2 different types of fur. You can create multiple fur instances. So I do this. Let's say the second fur is always colored black. I don't know, just making up examples. But yeah, again.
So I guess my confusion is that, like, is it the same? It's all just the same words as the class of fur, just for like continuity's sake. You know what I mean? Like, could you for in the class of mammal, like on line 17, just for shits and giggles, could you do like in the fur, could you do color underscore fur and like change the name of those?
These values are specified from whatever's passed in here. So these are just variables. Again, going back to function, we can name these variables whatever we need to. So yes, if I change this to like color fur, then simply I'm just taking these values, passing it down the fur so that fur can store those values on the instance. So the whole purpose of the init method is to take in values that are not tied to anything and tying them down to instance attributes. So again, if we want to follow the chain here, I'm creating Clifford, right? Clifford has a name, Clifford, type or breed is dog, weight is 4,000. I'm just matching it up to the list right here. Fur color is red, fur length is medium, and then fur style is shaggy, right? So that's what the user is passing in, or any operator or user of your class. So those values get passed right here. So then again, Python will automatically call your init method when you create an instance and pass the values you pass in the constructor here. So I get name, breed, weight, fur color. Again, these are just capturing those values. These can be named anything I want it to be. I could say color, fur something. Again, anything goes. It's just a variable that we are naming. So if I named it that, then that's what I'll need to pass down to my mammal, because mammal's the one actually storing the fur instance. So if I called it color for something here, that's what I need to pass down. But again, variable naming, it could be anything. So this name does not have to match whatever name I give it up here. So if I name that color fur, that's totally fine. It's basically capturing this value here, or sorry, yeah, it's capturing a value here, passing that value here, and then that's capturing whatever's passed here with this variable. I know that's kind of wordy, so hopefully I didn't lose you there, but again, these are just names that you can name these anything you want, and that's what you're passing down and creating variables for. So any name goes. Usually you just try to match it. Oops. Like
Yeah, that's kind of what I meant with continuity, is just like having it so you don't like make too many different words. But I see what you're saying, that it's just you're just creating a new instance every time and just building off that.
Yeah, so usually you'll see like the variable you pass in is the same variable you create. So self.name equals name. But again, I just change it up here or here also, just to kind of show that, again, it does not have to be named exactly what you're assigning it to. Like this is called fur, but I could name this anything I want. Variable names do not have to match anything, but class names are the things that need to be consistent. So this has to be named fur because my class is named fur up here. Great questions though. All right, any other thoughts about inheritance and composition? Again, just to review, make sure you take a step back, understand the relationship between your two classes. In our most recent example, a dog has fur. It's something that has fur. So the dog class should have an attribute that is of type fur, rather than inheriting from the fur type. Because a dog is not a type of fur, is something that has a fur. A dog has eyes, a dog has legs. So all those will be attributes inside of the dog class. Versus, a dog is type of animal, therefore you would use inheritance in this example because dog would inherit properties from an animal. All right, so that's inheritance versus composition. Just kind of understand, don't always just jump to use inheritance every time. There is a proper use and not use case for it. Next, we're going to talk about overriding and overwriting. Again, this is just more terminology, but it's kind of good to know about because it's used heavily with OOP and inheritance. Excuse me. So again, very similar sounding items and kind of similar ideas. But just know, when you hear the term overriding, that's the idea where you're creating something new to mask some existing functionality. All right, now I'm going to show an example of this so that we can solidify it. But again, you're just masking existing functionality. You are not replacing it entirely. As in, the original functionality still exists if you want it, but you have the option to override it. All right, so if you choose not to override something in a derived class, then it's going to default to the base class behavior. Overwriting, on the other hand, is the idea of actually replacing existing functionality. So you're just wiping whatever existed and putting something new in there. All right, so one, overriding basically covers or masks up base functionality. Overwriting replaces it entirely. So let me show an example of this. And I think this is the example I skipped over earlier. So it's probably a good time to get to it. I'm gonna take a detour from shapes and let's go to dogs. All right, so if you remember from Monday, we created a dog class that was similar to this. I'm gonna create dog.py. I'm actually gonna use separate files this time. So class dog, and we had a species, sound, legs. These are universal to all dogs, again, with exceptions maybe. But stuff like name, breed, and color are always different for each dog. All right, so that's our dog class. Let me create a new class called lazydog.py. I'm going to grab the code I wrote up here. All right, we have lazydog. Lazydog is very similar to dog and inherits from dog. Lazydog is a type of dog, but lazydog has additional behaviors potentially for it. And then finally, my runner file. So let me create my runner file. Say runner.py, and maybe create a folder. Again, this is this code organization. We're gonna definitely want to see you guys organize your code. So I create a folder for my animals, dog and lazy dog, just to organize my code. Don't have to, if I want to. And then my runner file is going to import from that. So when I'm importing, since I have this animals folder, I import from that folder dot, and then the module I want. So in this case, animals.dog, animals.lazydog. Actually, let's do from. So now I can use dog and lazy dog as I wish. All right, so we have two types of dogs here. We have Fido, which is just a normal run-of-the-mill dog here. Type pointer, color white. Fido can speak, Fido can fetch, but Fido cannot nap. Barkley is a lazy dog. Named Barkley, a bulldog, color gray. Barkley can also speak, can also fetch, and can also additionally nap. Let's actually take a look at our classes and then make sure we understand what's going on. So our base class is dog. Dog has some, some class level attributes, species, sound, legs. We have a couple of dunder methods, an init method, a string method, and then we also have speak and fetch. All right, so when we call speak, simply the dog will make it sound. When we call fetch with an item name, we'll fetch that item. So I guess I need to actually give it an item to fetch. All right, let's look at lazy dog. And maybe I should split screen here. If that would work for me. All right, so we have two dogs. We have, this is our base class. And we have lazy dog over here. Lazy dog pretty much is the same thing that dog does. So we inherit from dog, but it does one thing a little differently. That is fetch. So instead of just fetching whatever you give it, normally a dog's just gonna fetch, you throw a ball, the dog will fetch it. Lazy dog is a little more, temperamental, perhaps. I created a static method. Again, we talked about this. It's just a function that doesn't rely on anything about the class. It's going to return a random number. It's going to return true 25% of the time. So this is ready to fetch. We'll get a random number. If that random number is greater than 0.75, we'll get a true. And if you guys are a little confused here, so random is a method that's going to return a value between 0.0 and 1.0. And then again, I'm returning true here. One small tangent, because I know I've seen this in some students' codes. A lot of you guys are probably tempted to write it like this, and it's not wrong by any means. I just want to kind of get you in the habit of writing more condensed code. You can do something like, if this is greater than 0.75, return true, else return false. This is 100% acceptable code, totally fine if you write it this way. Just understand that this is a little more verbose than it needs to be. What I had before does the same exact thing, because if this is equivalent to true, we're going to return true. Else, if this equates to false, we're going to return false. If you catch yourself kind of writing code like this, where you have a condition that's going to be true or false, and you return true or false from that, you can condense that down into just a single line, where the result of this comparison is what you want to return, right? If this happens to be true, I want to return true. So I'm just going to return that comparison. So again, totally fine if you write it the other way. Just want to get you guys in the habit, or hopefully just the idea of writing more condensed code here. So again, random, return a value between 0 and 1. So basically, other words, it's going to return true 25% of the time. All right, so lazy dog, 75% of the time is going to be lazy. So if I look at my code up here, my fetch method is going to call ready to fetch. And if I get a true back from it, the dog is actually going to go fetch the item. Otherwise, dog is not going to fetch because it's a lazy dog. So this is an example of overriding. My base class has a fetch method right here, right? This function is overriding the base function of fetch. This fetch still exists. If I need to use it, I can still use it. But for lazy dog, it's going to prefer to use this fetch method because it's overriding the base functionality. All right, if you want to see this in play, let's go to our runner file. We need to fetch some items. Let's say ball to make it simple. Ball. All right. One more thing I want to point out. Sorry, going back and forth. Lazy dog has an additional behavior called nap. So lazy dog can take a nap. Let's say 4 hours. Lazy dog can nap. However, dog has no implementation of nap. So it does not know the behavior of nap. It's not an instant method that exists for, it's just a generic dog. So if I run this code, we will get an error on nap here. If we try to, insert a parameter, this will be an error because Fido has no concept of napping because it's a generic dog. So again, keep in mind, inheritance is a one-way direction, no relationship. Lazy dog is getting access to everything that dog has, but it's not vice versa. Dog does not get anything from lazy dog. What questions you guys have about inheritance or overriding here? So I'm going to run my runner code, but if there's any questions, please ask. Python runner. Hi.
I have a
Alright,
question.
Notice we got an error. We got an error that wasn't right. Yeah. What's your question?
The static method that overrides the instance of dog, you pretty much just copy and paste the instance, but you put it within the class of lazy dog, and then you put a conditional. That's how you override it?
Sorry, I missed that. We're talking about fetch, correct?
Yeah, because the instance is, it's pretty much the same function. You could copy paste it and then just like put the conditional, right?
It's almost the same. So
Yeah, it's almost the same. Okay.
yeah, fetch straight up fetches, but this lazy dog's fetch has a condition. It's not always going to fetch. So we're doing something slightly different here.
Got
If
it.
you're
Thank
talking
you.
about this behavior right here, we can talk about that maybe a little bit in a little bit. Because this is identical to what we have in fetch, what I've highlighted here.
Yeah, no, my question was like, it's just instance is def fetch, and it's the same here, but here it has like another instance where it's gonna like change what it does based on the random integer.
Okay. Yeah, so not finding my modules. Not sure why.
Like, I guess my point was that to override it, you need to call it the same thing, right?
Yes. Sorry. Yes, Guillermo is totally correct. You need to call it the same exact thing for that overriding to happen. There's no other magic way it's going to happen. Again, Python's going to look for a method. It's going to look at the local, like the current class. If it doesn't find it, it'll go to the derived class. So my error was in lazy dog, which makes sense. Lazy dog needs to import animals. Dog. Okay, cool. Now I'm getting the error I expect. Sorry for the poor coding there. Import statements got me there. All right, so our runner file, again, if you run the runner file that we have here, let's get rid of this. If you run this runner file, you're gonna get an error on this line 8, because Fido has no idea how to nap. Nap is not a method that exists. So I'm gonna comment that out. Let's run our runner file again and hopefully get full execution. All right, notice we get our output. We'll make that a little bigger. So we get, I am a white pointer dog named Fido. I have 4 legs and say woof. That is coming from print, because we have that str method. We can do speak, where Fido says woof, and then we go fetch. So Fido fetch the ball. Great, good job, Fido. Then we have Barkley. Barkley is a dog named Barkley. I have 4 legs and say woof. It's a gray bulldog also. Notice that when we did Barkley.speak, Barkley said woof. That's the same thing as Fido, because we're using the same sound, right? That sound is being inherited from our base class of dog, because if I look at my lazy dog class, there's no overriding of sound, right? Lazy dog says the same thing that dog says. If I wanted to override it, I could add a new sound here. Let's say lazy dog says meh. So if I did that, this sound would override this sound, because yes, they are named the same, and this sound gets preference for lazy dog. So if I ran this, notice I get meh instead of woof. And again, Barkley did not fetch the ball. Barkley is only going to fetch the ball 25% of the time. And that's random because of this. All right, so again, we talked about overriding. That's, again, I implement the same name method here that will get preference over the base functionality. It's basically masking it, but this function still exists. The difference with overwriting is if I did something a little differently in my runner file. So instead of having this fetch method here, let's comment that out, copy it, and maybe comment this out. All right, I'm just gonna copy this logic, go to my runner file, I'm gonna add these standalone functions here. So I have def fetch and def ready to fetch. Probably need to import my random module. Okay, that should be fine.
Indentation problem.
Yes. Hit eyes. That was one tiny space. Okay, so we have fetch and we have ready to fetch. And then we need random and we don't need self. Basically what I'm trying to do here is taking out this logic. So I have a fetch function and now I can overwrite the fetch function here. So instead of having the class do it, I'm going to do Barkley.fetch equals fetch, which is my function here. Let's say do fetch the differentiator. What I've done now is basically overwritten, again, overwritten with a T, the base functionality here. Because originally, the fetch method was this for lazy dog and dog. Keep in mind that I commented out, so this doesn't no longer exist. So lazy dog was using this fetch method, but now I've told it that your fetch method is now going to be do fetch. This is again sort of similar to overwriting, but now the base, like the fetch from dog, it doesn't exist anymore for lazy dog. So even though if you wanted to use it, you couldn't because you overrid it with another value. All right. So again, it's subtle, but the difference overwriting, you're just masking some base functionality. Overwriting, you're totally replacing what existed before. Questions?
I had a question, not really directly related to what you're talking about, but the export on runner, I think you or import, I should say, the animal.dog and animal.lazydog from dog and lazy dog. Could you just take the from off of that and import dog and lazy dog, and it would bring all of the functions?
You could do this, but if you do it this way, you're going to have to append animals.dog to all of those.
Okay.
Yep.
And you
could do
can't
it this
just,
way.
you can't pull the whole, you have to specify each individual function that lives within lazy dog or dog. You can't pull kind of all of the methods all at once.
The methods live in the class, so you had to pull the class in. So if I had multiple classes, I could pull in multiple classes. So I could do, instead of this, I could do a star operator, which I think someone else mentioned. But in this case, I only have one class to import from each of them, and that's the ones I'm specifying here. So again, I'm not individually importing methods. I'm importing the entire class, which has methods inside of them.
Okay.
Yeah.
I'm just, I guess what I'm trying to, if you took the from animals.dog off and just left it as import dog, what would you?
You can't have import dog because the module is in the animals folder. So you still need animals.dog for it to find the proper module, because I put in a folder. If I didn't put in a folder, like if I moved it out here.
Oh, and animals/dog.
No, it's going to be dot.
Okay.
Yeah. So even though it's a folder, you're not using file paths per se. You're still going to use the dot to get to that through that folder. If I move the dog out here, then I would simply do dog. But if you add folders, again, you're going to add folders for better code organization. If I move this into the animals, then I need to tell it to look in the animals folder module per se.
Okay.
That's just the naming convention for imports.
But okay, so just so I'm understanding right, that on line 1, you would get all of the modules that are in the dog class by doing what you did in line 1.
Yes, but then if I need to access them, basically I'm saying, give me everything from the dog class. Same way I'm doing random. Random has a bunch of functions inside of it, so I could just do. That's probably not what I want. Random.random. But yeah, so either you could get everything, or you could individually pick out what you want. I'm just doing it this way, so I don't know how to keep writing animals dot.
Okay.
Okay, cool. So that's overwriting. Again, can be confusing. Just kind of understand there's a difference. If someone says overwriting something, you should know what it means. If they say overwriting, understand the difference there. Okay, we're going to talk about.
I'm sorry. May I ask you a quick question about just terminology? when you say module, is module referring to a .py file or is
Yes.
module referring to a class?
To a .py file.
Thank you.
Yep, great question. All right, abstract base class. I think in the interest of time, I'm gonna skip over this. Again, this isn't crucial to know. The 20,000 foot view of this is basically, you can create something called an abstract base class that essentially forces any derived class to have certain functionality. Maybe a good example, if I still had it up, we have our shapes up. Let's say shape, for example. Let's say we want to require an area function, but right now there's no area we can compute here, right? We could return none, but that's kind of confusing because like if a derived shape happens to not implement area, it's gonna be kind of wrong to return none. Like that shape should be responsible for calculating its own area. We just can't do it for like a generic shape. So the idea here is you can specify this to be an abstract base function, where you do something like, I'm gonna do this quickly. Again, you're not gonna do this in our coding challenge or anything like that, but the concept is sort of interesting to know about. So ABC is abstract base class. We import ABC, and then we would inherit from ABC, and then there's also abstract method. So this is the syntax. If you're totally confused by it, don't worry about it. Don't spend the brain cells to kind of memorize it. Basically, what this is saying is any class that inherits from shape must include an area method. They must override this method. If you do not, Python will raise an error, as in it won't let you run your file. It'll say, hey, you tried to implement a class that's an abstract base class, and you didn't override functionality that was specified to be overridden. So this abstract method says, hey, this actually doesn't exist. You got to create your own. And it forces you to do it. And sometimes you want to require that. Reasons you might want to do that is, for example, let's say I had a function called print area, def print area, and that's all I want to do here is print area. Well, this is totally fine because I am relying on every derived class to specify area, but all of those, sorry, let's be self. All of those derived classes can use one print area method because they're all going to do the same thing, which is simply call the area function and print it out. So instead of having 50 different copies of that in 50 different derived classes, my shape class will have one print area method that every other derived shape can call, but this must be implemented in all of those individual shapes because, again, computing area is different for each type of shape. Anyway, that's the general idea of abstract base classes. Don't worry about it if you don't want to pay attention to it. Example. All right, let's talk about the MRO. And I know we're approaching lunchtime, so we'll try to wrap this up. MRO. This is basically just a predefined way that Python resolves conflicts. And so this is something we tabled from earlier, which was, hey, what if we have two area methods, which we had with rhombus and rectangle when square was inheriting from it? Well, how do we actually know which one's going to be used? There is a ordering precedence, and it goes left to right, upwards based on derivation. You can use the class name __MRO _ to see the actual MRO for a given class. So let's look at a simple example. If you choose to inherit B1 and B2, or derive C1 from B1, B2, again, the MRO is going to go left to right. So B1 is going to get precedence over B2. If I go to my code, the way we'd implement that is if I have a class B1 and then a class B2, the order you specify in your inheritance determines the precedence. If I do class C1, it inherits from B1 and B2. Pass. If there's a conflict, B1 will be searched before B2. And it's because I specified B1 first in my list of inheritance. If I swap them, then B2 would get the precedence. So a simple example is if we have a method def print something, takes in self, print B1, def print something, self, print B2. All right, so I did this simple example. Let's create a C object, C1. All right, notice that C1 doesn't really do anything. That's fine. If I do Python lecture C dot print something. All right, so notice we get B1 printed out. Again, that's because we have a conflict when we call print something. The first thing Python does is going to check C1 to see if print something exists. In this case, it does not. Now it's going to go to base classes. So it's going to search B1 first and say, hey, do you have something called print something? Great. If you do, I'll use it. If not, it'll search in B2. Now, if we had print something in C1, it should print that out. So if I have C1 here, it's going to prefer this one because obviously this is the object of the type that we have. We have a C object. So if I do this, notice we get C1. You could print out the MRO. So if I do C dot, or sorry, C1 MRO. Again, the MRO can be kind of confusing, but just want to let you know that it exists. And this is how Python determines how to resolve conflicts. So notice it gives me a list. So C1 is first in my list, B1 is second, B2 is third. This is the order of precedence. C1 gets searched first, then B1, B2. If I swap B1 and B2, the precedence should change. So B1, B2. Again, doesn't matter when you declare them, like B1 is declared before B2, but that is not what is impacting this. So notice now B2 is second in my list. So if I got rid of my print something here, I should get B2 from this line. All right, so that's how any conflicts are resolved. And that can be important to know when you have multiple classes you're inheriting from. So that was a simple example. We can get more complicated. So again, if we're looking at D1, it's going to go left to right, top down. So in this case, again, this it's kind of hard to parse, but C1 would get precedence. Then it would be B2 because they're both directly inheriting here. Actually, I would need to double check that, but D1 inherits from C1, C1 inherits from B1 and A1. So C1's MRO would be B1 and A1. For D, it would be C. Then I believe B1 would come before B2 because they're at the same level. And then A1 would be at the very end. So if I did this, let's code this up, class A1, class A1, A1, then we have B1, B2, which derived from A1. So again, you don't have to memorize this. Again, you can inspect the MRO. It's just the idea that there's an ordering. It's not random. A1. So we have that. We need a C1, which inherits from B1 and A1. And finally, we have, so that is C1. And then we have one more class. Complicated example, but again, class structures can get complicated. So in this case, D1 is inheriting from C1 and B2. If I do C1, oops, not there. C1 and B2, we should be able to print out C1. All right, so the MRO, if I print out for D, should be, if I calculated it correctly, looking at this, it should be C1, B1, B2, and then A1.
Shouldn't D1 inherit from B2 on line 18?
B2. Yep. You guys always catch it. Clear. All right, let's print out the MRO. All right, a little hard to read because it's all on one line, but notice we get D1, C1, B1, B2, A2. Again, the levels actually matter. It is confusing. I'm not going to say, oh, you should get it like that. But again, C1 is at a different level than the B levels because of the derivation here. So D1 goes to C1, and then B1 and B2 are at the same level, so it goes left to right. If I swapped B2 and C1, the order would be D1, B2, C1, and then B1. Again, a lot of letters I'm throwing around. Don't worry about it if this example kind of lost you. Just understand there is some method to the madness. It's not going to be random when you have conflicts.
Just an FYI, you won't see this in our cohort.
Yeah.
This is
Uh,
more
just
advanced
kinda
topics.
interesting. There is a link on our cohort page if you're curious reading about it more. You can read about it, but main reason for the MRO is to talk about super. All right, and this is the last thing we're going to cover, so almost done. Sorry to eat away at your lunchtime, but super. Yaping mentioned it earlier. Super is a method that automatically calls the proper base class, right? And that's important because sometimes we might not be able to determine the base class, but also it gives us a little more robustness. So if I went here, let's say my print something wants to call a base class. One way I could do it is call C1 and do print something. I need to pass. So if I simply called C1, this is explicitly calling a class. So I probably need to pass self here. See if this works. Yeah, so notice we get C1 and D1. Well, the reason we got C1 above is because we called it before printing D1, right? We're explicitly calling it here. But what if hypothetically, C1 wasn't the first class here? What if we add a new class called like C2? Well, if we add a new class here, we're probably gonna need to change this. Or I guess a simpler example, what if we rename this class to be like C something? Right? Think about on a large scale. If we rename this, sure, we're gonna have to, no matter what, rename this because there's no way around it. We gotta tell it the proper base class. But every time we mention C1 in here, we're gonna have to replace it with a new name. While that might sound easy, again, it could lead to more bugs. You can, forget a spot. Consider we had like 40 different methods in our class. We gotta replace every single instance of C1. Instead, we can use the super keyword. This automatically knows the duration order. It looks at the MRO and says, all right, what's the next base class I need to call? So if you just do super, you should not have to pass it in self. So I do super print something. It'll do the same exact thing I was doing before. Hopefully I didn't break anything with renaming. So notice I still get C1 and D1. Super knows that C something, let me rename it to C1, is the next base class in line. Again, this is beneficial because super kind of abstracts the details away from us so that if our ordering changes here, for example, if I change this to be B2 and then C1, our ordering changed. Therefore, but I did not have to change this line of code. That line of code still knows the proper base class to call. So if I do this, notice I get B2 now. I simply swap these, super stayed intact. So when you do need to call a base class or functionality, use the super keyword. Now, if I go back to my lazy dog class, let me uncomment this. Something that you might have noticed was that my fetch here, when we fetch something, is the same exact code as a fetch right here. That is duplicate code, and that usually is frowned upon. So instead of reinventing the wheel here, or kind of duplicating that code, I could simply call super and call fetch. This is not going to call this fetch method. This is properly going to go down to the base class and call that fetch method. And this is better design because now if I want to modify my fetch method, let's say I want to add a bunch of exclamations, I only need to do it in one single place. Instead of having to also go to my lazy dog class and also updating it here, right? That's redundant work and that's prone for bugs. Because again, this is just two different places. What if I had 30 different places that had the same exact code that kind of needs to rely on each other? It makes much more sense and is the proper way to do it by calling super and then calling the base functionality if you want to reuse that functionality in a derived class. So super fetch would do the same thing. If we are ready to fetch, it's going to call this method in the base class. So again, just use super. There are rare cases where you need to specify the class name. If I go back to my alphabet soup in my lecture. So here I'm calling super and I'm saying call the proper base class. But hypothetically, if I absolutely needed to call C1 and I don't want to call the next class in line, that would be a case for manually specifying, all right, I definitely want to call C1. I don't want to call B2. All right, so you can use the class name if you absolutely want to specify exactly what to call. Otherwise, most cases you should be using super because that's what your logic should be doing. So if I add a super to all these methods, let's see what happens. What question do you guys have out there? Was there a question? Sorry.
Yeah, so my question was on the fetch method. Is the super call calling self?
Is the super call calling self? Could you clarify that for me?
Yeah, yeah, so before I was understanding that the super calls the first imported item into
Yeah, so super
into
effectively is
that
calling
function.
dog.fetch, and yes, it is passing self, if that's what you're saying. So super, if you read more about
Okay.
it, actually takes in parameters if you want it to. This is kind of a shortcut. So super would specify dog and self here, and you can specify those parameters, and these will be passed to your instance method. But for convenience, if you just leave off these parameters, they'll automatically know to pass self here.
So it's calling the class and not a function per se.
No. It is calling the instance method. So fetch is an instance method. So yes, it is passing self here automatically, like automagically, I'd say. This is not a class.
I mean, the super call is basically saying call dog.fetch.
No,
Is that
it's saying call self.fetch. Again, it's kind of mysterious. There are parameters here. So
okay?
for super takes in two parameters. It tells you which class to call and what instance to call it upon. Right here, we don't need to specify dog because dog is the only base class. But if we had like more base classes here, like we had, animal also or whatever, say something. In this case, if we want to call a specific fetch, we would call something with the self. But again, it's still an instance method. So you're not calling it on the class, you're calling it on the instance still. Super kind of just handles that for you. So again, this is calling an instance method. All right,
Okay.
so question? All right, so I modified my example word soup here. I'm calling my base class for every method. So if I ran this in my terminal, oops, if I did Python, running here, lecture, UI. Super objects. All right, I screwed something up here. Let's kind of move on here. But again, the idea here is I could call every base class that I wanted to here. Line 4. Oh, okay. There's no. So here I'm attempting to call super for my very, very base class. The base of this does not have a print something. So that was my error. So if I clear this, run that. All right, there we go. So we get A1, B1, C1, B2, D1. Again, it's like in reverse order because I'm doing the print something first, the base call first. If I put this after my print statement here, this would show the proper MRO, like top down instead of down up. But anyway, all right, key takeaways, and then we'll wrap up with questions. Know what inheritance is. Again, just kind of understand the idea of sharing properties from a parent class to a child class. That's the whole idea of inheritance, kind of reusing that code and functionality. Just know the different types of inheritance models. Again, just on a high level, understand when to use which. Again, you might have multiple inheritance, multi-level, you might have hierarchical, you might have some crazy combination of it. Just do whatever makes sense for whatever your design requires. There's no set case that you have to use this for that. But again, your design will dictate how your inheritance model is set up. Again, know the syntax for inheritance. Again, simply parentheses after your class name. So we saw that multiple times like this. This means that B1 is inheriting from A1. Just remember those parentheses. If you don't need to derive from anything, parentheses are optional. So this is the same thing. No difference there. Know the difference between class inheritance and class composition. Again, that was just the idea of if you have a is a relationship, use inheritance. If you have a has a relationship, use composition, as in have an attribute for whatever that data is. Don't use inheritance. Again, this is totally separate from creating classes. For our, for example, it was still totally fine to create a fur class, and I almost would recommend it. But again, the way you store the data is via an attribute instead of using inheritance. Finally, the super keyword. Anytime you want to call a base class, rely on a super method instead of kind of hard coding what class to call unless you need to call a specific class. Super will do all the hard work for you. It'll know the proper MRO to follow through. So again, we talked about the MRO. Don't worry too much about that. I know that's confusing. Just understand there is a method. There's a precedence that's set in place by Python. That's what super is going to follow each time. So for my alphabet soup here, I call super repeatedly. It's going to bounce basically from each base class in order to the next class in line. So this is doing stuff in the proper order. All right, so again, a lot to it. I don't want to kind of freak you guys out. So again, the main takeaways: no inheritance, no composition, and know how to implement them in Python. Don't worry too much about MRO or abstract base classes. Again, definitely more advanced and nothing that you guys are worried about for now. Okay, what questions do you guys have about inheritance? Okay, I'm going to assume that you guys are still digesting it. Again, reach out during afternoon as you guys are working on challenges. We'll definitely go over it again at stand down because I'm sure questions will pop up through challenges and maybe kind of reviewing the lecture. Let's actually look at our challenges for today.